Lesson 8, Launch, Explore, Discuss. What does it mean? What does it all mean? And mean is also a play on the word average. You'll see arithmetic mean is one of our vocabulary terms. So for a jump start, most students had no problem filling this out, coming up with the next terms, figuring out how much they should jump to get to the next number. In this case, jumping by 4. And the next one, going down by 7. And coming up by 12. But what happens if there's a gap inside of the table? How can we figure that out? Well, there's a couple of different ways you could do it. One way you could do it is just guess. So, in other words, 5 plus something, and then that something plus, to get 11. Is it 2? 5 plus 2 would be 7. 7 plus 2 would be 9. No, that's not it. How about 3? 5 plus 3 is 8. 8 plus 3 is 11. So that works. So apparently the answer is 8. But how to get 8? Well, that method is called guessing and checking. Just guess until you get the right answer. That can be time consuming. It doesn't really work so well when you don't have whole numbers, like when you have decimals and things like that. Another option that some people figured out or could figure out is that if you average the two numbers, 5 and 11, average means add them together and divide by 2, then that will give you the middle number. But that doesn't always work so well. And so here's a better way to do it. Think to yourself how many jumps it takes to go from 1 to 5. 1, 2, 3, 4. Okay, so that is basically 5 minus 1. How many jumps does it take to get from 18 to negative 10? Well, it's the same. It's 5. It's going to be 4 jumps. But how far do we have to go? Well, from negative 10, actually from 18 down to negative 10, you're going to have to go down 28. So see if this makes sense. If we have to go down by 28, and we have to do that in 4 jumps, that means that each jump is negative 7. So really what's going on here is we are subtracting the y values and dividing that by the subtraction of the x values. So, question I posed in class, does that sound familiar to you? Does subtracting the y values divided by subtracting the x values sound familiar? Well, this is called the slope. The change of the y divided by the change of the x, or in other words, y2 minus y1 over x2 minus x1. It's the slope. The slope formula is the method that will work. And the reason it works, how do you know it works, is that, remember, we can take a table and we can turn a table into points. I can think of this as the points 1, 12 and 7, negative 6. Apply the slope formula, and there we go. So this will go 9, 6, 3, 0, negative 3, and then, of course, negative 6. So it works. So here's a few more. 86 minus 50 divided by 4 minus 1. So that's 36 over 3. That's 12. Go up by 12, you're going to get to 62, 74, and then it lands right on 86. 40 down to 10. So take the second one, take 10 minus 40, and subtract 6 minus 1. And you get negative 30 over 5, or negative 6. So this goes down by 6. This goes to 34, 28, 22, 16, and then 10. And the last one is 5 minus negative 23. So you might, 23. So you might have a double negative over 8 minus 1. So 28 over 7 or 4. So it goes up by 4 to negative 19, negative 15, negative 11, negative 7, negative 3, positive 1, and then 5. So this is the method that you would use for number 8. This works for arithmetic sequences, by the way. All of these have been arithmetic. So what's our takeaways? Well, simply that you could do it in words. If you take the last number minus the first number and you divide that by n minus 1, you're going to come up with d, the common difference. And then take the first number and add, as many d's as you need to fill it in. In our retrieval section, we're just remembering this stuff, looking at this stuff again. Analyze from term to term how you're changing. This one is geometric. You're dividing by 2. Therefore, the recursive f of n is f of n minus 1 times, let's say, 0.5. Or let's make it a little more clear. How about we'll put it in parentheses, 0.5. Explicitly, we're starting at 112. We're multiplying by 0.5 to the n minus 1. On number 2, we're increasing, but we're not increasing by the same number every time. We're going up by 5, up by 7, up by 9. It is a pattern, but it is not arithmetic or geometric. We don't have to do these then. And the last one goes from negative 30 up to negative 13. That's up by 17. Up by 17 more, that makes it arithmetic. Where the f of n is f of n minus 1 plus 17. Explicitly, that start at negative 30 and add 17 to n minus 1. And here we go. We'll see you next time.